Hello everyone, I am Nitin D from 3rd year Mechanical Engineering Department. Now we are going to see about the topic Economics involving advanced machining process. First, what is meant by advanced machining process? It is a material removal process in which a well-guided machining tool removes material by mechanical means such as chip forming, microchipping, etc. If the workpiece is too hard or brittle like glass ceramics or too flexible, or if the shape is too complex, we cannot go with traditional machining process. So there is a need of advanced machining process. So we adapt advanced machining process. These two are the products that are made using advanced machining process. Next, some of the types of advanced machining process: chemical machining, electrochemical machining, electrical discharge machining, laser beam machining, electron beam machining, plasma or cutting, ultrasonic machining. In that electrical discharge machining, we have two types: wire electrical discharge machining and ram electrical discharge machining. Then the economics of advanced machining process includes the first and foremost is the cost, which includes the initial investment, tooling, and the equipment cost and the operating cost, etc. And the type of tools used, which may be hard tool or soft tool or maybe both. And the production rate, which may be high production rate or low production rate. Then the repeatability of the process, how long we repeat the process so that the production rate will increase and also the cost may be also increases. Then the operating skills required. The high skilled operators are necessary for advanced machining process. Next, the classification of cost element. First, the equipment cost. Equipment cost, which is the initial investment in raw materials, machines, etc. Then fixturing. Fixturing is a capital asset in accounting, which includes how it expensed, percentage deduction, and the expenditure, expected tax, etc. Then cost of tools, which may be hard tool or soft tool, as I mentioned earlier. Then the maintenance cost, then the life of the machine, then the power consumed in a period of time, and the working medium where we are using. These are some of the cost elements. Next, the effect of products. The effect of products play a great role in economics side. Some of the products which include in advanced machining process is in chemical machining, the cost of the reagents, masks used, etc. Next, the excimer used in laser beam machining. Then the magnetic lenses used in electron beam machining, and the electrodes used in electrical discharge machining, which is need to be replaced periodically. So these are the products that play a major role in the economic side. Next, the factors in machining economics. Some of the unknown factors that play a great role is modern carbon materials, which will generally give a speed of about velocity in the range of about 300 to 1000 feet per minute. As the unit machining cost is practically constant for a variation of 200 feet per minute in V minimum region, modern carbon materials are very useful in advanced machining process. Next, the factor to be considered is tool breakage. Statistical report shows that incidence of tool breakage affects the grinding cost, which allows the cost to be approximately increased by 100%. Next, the economical scale. The scale is between the traditional machining and advanced machining. If the product is produced by traditional machining, the initial cost is very high, and as the number of units increases, cost is reduced. In advanced machining, as the graph is inclined, we come to conclusion that the cost is low, and also as the unit increases, the cost will automatically reduces. Next, the optimization of machining economics. Focus to be made on maximizing the product and minimizing the production time. Main attention is avoiding energy losses by selecting proper cutting parameters. Next, the advanced machining process integrate agile manufacturing. Agility means to be ultra flexible in tooling and also in automation. It improves cycle time reduction, which means more product can be turned out in a particular period of time. Then high machine uptime, which means how long the system is running. Then machine minimum machining process, which play a great role in the economic side. Then reusable transfer lines, which is the automatical material handling system, which is to be useful in next generation of products. They complete the agile process, which play a great role in the economical side. That's all about the economics involved in advanced machining process. Thank you for your patient listening. Hope I made it clear. Now we look into a video.
From high labor cost and shrinking domestic market to slow trade deregulation, the environment surrounding domestic manufacturing sector is becoming increasingly dire. To overcome these challenging situations and continue domestic production, manufacturers must reduce their cost further. Manufacturers must build automated production lines, running stably 24 hours a day, 365 days a year, to meet their cost reduction target. One key to automation and productivity improvement is reducing cycle time and chocote. This effect is called CT effects, using the initial letters from cycle time and chocote. Chocote is a Japanese term referring to a brief stopping of a line. More specifically, it refers to when a line is stopped briefly due to a simple mechanical or electrical problem with an automated machine, but can be fixed quickly and resume operation almost immediately. Equivalent English terms include ceased time, frequent stop, short stoppage, and temporarily ceasing. Now, let's take a look at two examples of successful production cost reductions resulting from CT effects achieved by motorization of line. Now, this is an example of a semi-automated machine that assembles onboard sensors. The steps are as follows. The operator puts a part on the work table and presses the switch. The work table moves forward and a connector is press fit and conductivity is checked. Thereafter, the work table moves slightly backwards, and after an inspected and accepted stamp is pressed, the work table returns to the initial position.
It is an example of automatic transfer.
This semi-automatic machine uses an air cylinder, and the cost of one system is $50,000 per machine. One machine requires one operator. It took the air cylinder system 14 seconds to complete the tasks explained earlier.
So the production rate will be increased.
When a system having the same function was designed with a robo-cylinder, it took $55,000 to build one machine, which is $5,000 more than the air cylinder system. However, the robo-cylinder system can complete the same tasks in 10.2 seconds. In other words, the cycle time of the robo-cylinder system is 3.8 seconds shorter than that of the air cylinder system.
In this video, we see two products that reduces the cycle time, so the production rate automatically increases and also the production cost decreases. Thank you.